Hey everybody, um, welcome back. Today we're going to be taking a look at our practice test for our exam tomorrow. Now I know I didn't put like an intro video here, but I figured I just want to kind of jump right into it. This is what your test is going to look like. Okay, so we're just going to get going with it. Number one, given the expression 5n plus 4, identify the first six terms of the sequence. N equals 1 represents the first input. All you're doing here is putting in 1, 2, 3, 4, 5, 6 for your n, okay? Because the first term is going to be when n is 1. So if I plug a 1 in here, 5 times 1 is 5, plus 4 is 9. If I plug a 2 in there, 2 times 5 is 10, plus 4 is 14. 3 times 5 is 15, plus 4 is 19. Can you see how we're going up by 5 each time? So you can continue your pattern. There you go. But all we're doing, if you want to find the 20th term, all you do is plug a 20 in for n. Multiply it through. Got it. Okay. Number two, draw a graph of a relation that is a function. Draw a graph of a relation that is not a function. All right, so explain two ways we can determine whether or not it's a function. So here's function. Here's not a function. Okay, so a function would be something that's linear. And that's a good example, even a parabola, so on. It passes the vertical line test. If I draw a line straight up and down, it never hits more than one time. Okay? It's 1 to 1, meaning the x values are not repeating. Meanwhile, not a function would be something like this. Okay? Because if I draw a line straight down, it hits 1, 2, 3. The second it hits more than one time, it's not a function. Fails your vertical line test. This would be like a point like 1 comma negative 6. 1 comma negative 1, 1 comma 6. Okay, so like you can see how the ones are repeating. Explain the difference between the domain and range. So identify the domain and range for the functions you drew in problem 2. Domain is all x's. All x values. Right? Your range is all y values. I probably didn't draw the best graph up here, so let me show you guys another one over here real quick. That will be a better example. Here's an example of a parabola that touches down at 0 and then rises up. The domain for this one would be all real numbers. All real numbers. Because I go left forever, I go right forever. All the x values are getting hit. Meanwhile, my range, you're going from bottom to top. Okay, so it starts at 0 and it goes up forever. So it's all numbers greater than or equal to 0. Okay, so when you're looking at a graph, domain, look left to right, range, look bottom to top. What does it mean to be linear? Write an equation that represents a linear function, and another equation that represents nonlinear. So linear would be something like y equals 3x plus 2. It's in the form of mx plus b. Meanwhile, nonlinear would be something like y equals 2x squared plus 3x minus 2. Anything that has, if your x is changing, x squared, x cubed, x to the fourth, this would be nonlinear. Okay? Awesome. Write the equation of a line that goes through the points below. I want to find slope. So here's my x1, y1, x2, y2. Your slope is, I'm doing 3 minus 5 divided by 9 minus 3. So negative 2 over 6, negative 1/3. Bad 3. Okay. So back to mx plus b, here's my equation, or my slope rather. I'm going to pick one of these random points. I'm going to go with 3 and 5. So the 5 goes in for y. My slope is negative 1/3. My x is 3. 3 times negative 1/3 is negative 1. Add it over. B equals 6. So my final equation is y equals negative 1/3 x plus 6. Your whole goal for all these, if we covered all like the past week, this is your slope, this is your y-intercept, that's what you need to write an equation of a line. Okay? The value of a stock is doubling every 7 years. Explain why this does not represent a linear relationship. Okay? Linear is constant change. Constant. something that's doubling every year. Like, so if I start out with $100, next year I'd have 200. Okay. If I doubled again, I'd go to 400. So I'm not changing by the constant rate here. I went up by 100 here, then 200, then I'm going to go up by 400, so on. Okay. So it's not a constant change. Exponential growth is way different. Number 7. What is the slope of a line that passes through the points -3, 18, 86? Okay, again, here's my equation for slope. Right, so we get 6 minus 18 divided by 8 minus -3. I get -12 over 11. So there's my slope, okay? Now if I plug it back into y equals mx plus b, I'm going to plug this one in. I just randomly picking one. It just looks nicer. 6 equals -12 over 11 times 8 plus b. -12 over 11, I'm going to go to my trusty calculator. Times it by 8. I get -8.722. Or -8.7272. Plus b. If I add that over, I get -2.72, etc. Okay? So y equals mx plus b, y equals -12 over 11, x minus 2.7272, repeating. Okay? All's good. So it's again the same process over and over again. You and your sister made 3,500 designer bracelets this past year. Since she was the lead designer, she took 60% of the earnings. How much did you earn? Well, if she took 60%, that means you get 100% minus 60 is 40%. So if I do, like, in terms of decimals, 1 minus 0.6 will give me 0.4. So we're just taking 3,500 and multiplying it by 0.4. So 3,500 times 0.4. It's really hard to see this. 1,400. So out of your profits, out of the whole total profits, you're getting 1,400 of it. Not a bad racket. All right. On the back page, here are open-ended questions. A transportation company in a large city charges passengers a flat fee to enter a cab plus an additional fee per mile driven. The equation y equals 1.15x plus 5.25 represents a total fee y for driving x miles. Identify the value of the y-intercept and explain its meaning in the context of the problem. Y-intercept is when x equals 0. So if I plug x equals 0 in up here, I get y equals 5.25. That means if I go 0 miles driven, the second I get in that cab, I owe him $5.25, or her. Okay? Identify the value of the slope and explain its meaning in the context of the problem. 1.15, because again, mx plus b is my slope, and that's the amount of money charged per mile driven. Money for mile driven. Okay? Ooh, that's bad. All right. Electric usage for a repair company was charged over 4 months. Write an equation to show the amount changed for a specific number of kilowatts per hour. Show all work. So again, I'm doing my slope here. I write it up here. X1, Y1, X2, Y2. I got 172.64 minus 94.56 divided by 1,079 minus 591. I'm going to go ahead and put this right in my calculator. Okay, so 172.64 minus 94.56, 7808, divided by 1,079 minus 591, 48. So 78.08 divided by 488 gives me a slope of 0.16. If I do mass fraction, enter, 4 over 25. Okay? So, back here, I've got my slope. Now I'm going to go to mx plus b. I'm going to pick one of these points. I'm just picking the first one. It doesn't matter if you pick any one of these, it'll still work. Here's my y, 94.56 equals 4 over 25 times 591 plus b. So 4 over 25 times 591 gives me 94.56. Okay, subtract that over. B equals 0. So my equation is just y equals, or actually in this part, they want a and k, so a equals 4 over 25 times k. All right, now think about that. Use the equation you found above, determine the amount charged if 2,036 kilowatts were used. So a equals 4 over 25 times 2,036. Come back to here. Show us you can actually see it. Parentheses 4 over 25 times 2036. We get $325.76. Explain how you know the y-intercept must be 0. Well, think about real world. If you didn't start any or use any kilowatts, you're not going to be charged any money. So no kilowatts, no charge. Okay, awesome. Okay, just a few quick more. Leroy is going to state barbecue cook-off with his friends, but can only stay for 5 hours. The event offers 2 different pricing structures. Leroy can purchase an all-day pass with unlimited food samples for $30, or he can pay an admission fee of $6 and pay $3 for each barbecue item. He is planning on trying 7 barbecue items. Which deal should he take? Show all your work and provide an explanation as to how you arrived at your conclusion. So option 1, okay, is $30. Flat fee. You get to eat what all you want. Option 2, it's $6 and $3 for every item he eats, but he wants to eat 7. So 3 times 7 is 21 plus 6, $27. Now imagine this is you. What would you rather spend, 27 or 30? Obviously 27. So for an explanation, just write, overall, spending less money. And again, I'm kind of shortening this because I don't want to run out of time for this video, but really sell that. Explain how, for the situation at hand, we know that Leroy only wants to try 7 barbecue items, so it's in his best interest to go ahead and take option 2. Okay? All right. Now, as far as this last one goes, we'll get you guys started here. A researcher collected the following data showing the number of hours per day that can spend on the computer versus the number of pounds that they are overweight. Okay, hours, pounds overweight. Here's our scatter plot to go with it. So draw a line of best fit for the data set above. I'm drawing a line that goes the best through it as I can. Again, your line might be a little different than mine, all right? I'm identifying a few points here. So this is 4, 25. Here's another point, 8, 40. Okay. Using a line of best fit, predict the number of pounds overweight a person who spends 10 hours a day on the computer should be. So 10 hours is right here. If I come up, roughly about 47 pounds overweight, just using my data set to figure it out. You come to 10, go up, go over. Okay. So 47 pounds. Calculate the slope for the line of best fit you drew. Show our work. All I would do is use these 2 numbers that I pointed out. Again, yours might be a little bit different. All right. You guys can set that up. It would look like this. 40 minus 25 divided by 8 minus 4 and solve for that. And lastly, I interpret the slope you found using the context of this problem. Well, the slope is positive slope. Obviously, the more hours you use on the computer, the more you're overweight in the context of this problem. Okay? So if you guys can handle this, you're going to be in terrific shape for tomorrow's exam. Again, I really feel like you guys can rock out in this and do well, and it'll help boost everyone's grade. If you have any questions, please don't hesitate to ask in class. That's what I'm here for. Again, as always, keep up the good work and good luck. We are all counting on you.